This presentation will discuss how the Aquamonitrix monitor is helping customers to better understand and control wastewater treatment processes through the simultaneous selective monitoring of nitrite and nitrate. The presentation is in 4 parts. We will be looking at who are Aquamonitrix. Then we will go on to discuss the key value propositions. We will then move on to how the monitor works, and finally we will cover some areas where we can help you. Aquamonitrix was born out of a desire to make the most of the experience and knowledge of the founders of the company in high quality laboratory-based analysis. There was and still is a need for high reliability, accurate analysis of nutrients in water. Ireland is a green and wet country. Our rivers and our lakes are important to us. How does the analyzer work? How does it deliver such high accuracy and reliability? Aquamonitrix is a patented monitor. It combines 2 techniques: rapid ion chromatography and LED UV spectroscopy. Key to the accuracy of the instrument is the fact that the ion chromatography column separates the nitrite and nitrite ions to allow selective detection. This selectivity means that high accuracy is possible even with varying and very different concentrations. It also means there are no interferences. The monitor also benefits from very stable calibration. There is no need, for example, to recalibrate the monitor if the sample composition changes. In this way, the Aquamonitrix is matrix independent. We will now see a video of how the monitor works. An internal sample pump pulls a sample from the media to be measured. The first 20 seconds are a flush of the previous sample. The sample reservoir is then filled and a syringe pulls a sample into the system. The microfluidic volume is then mixed with eluent, which is also delivered by 3 syringes. Mixing occurs and the sample mixed with eluent is injected into the column for analysis. The column separates the ions, with nitrite ions moving more quickly through the column. The separated ions then go through a UV detection cell for analysis. We see the injection peak, followed by the peaks of the 2 ions of measurement. What are the value propositions? What can we deliver? Many processes are using outdated controls. In sewage treatment, for example, dissolved oxygen is a key control parameter. Measuring nitrite and nitrate in wastewater treatment processes allows operators to optimize the set point for dissolved oxygen. Instead of running the process with a fixed dissolved oxygen, it will be possible to change the dissolved oxygen set points depending upon nitrite and nitrate concentrations. Nitrous oxide is a very powerful greenhouse gas, 300 times more powerful than carbon dioxide. Measuring nutrients in activated sludge processes is allowing operators to optimize process control to reduce nitrous oxide emissions. Net zero involves a balance between energy use and emissions. Measuring nitrite and nitrate is a key part of advanced wastewater treatment process control to allow operators to make progress towards net zero. The monitor also delivers value in environmental monitoring. If a process operates cleaner and greener, there will be less cleanup costs. there will be less risk of costly fines. Final effluent monitoring also allows operators to determine if their process is operating optimally. The presence of, for example, nitrite in final effluent is an indicator that denitrification is not occurring. What kind of numbers are we able to deliver? In the area of nitrous oxide emissions, companies such as Cobalt and Royal Haskinen have developed models and tools that will allow operators to reduce nitrous oxide emissions by as much as 70%. Integral pieces of data required for these models include nitrite and nitrate. Advanced nitrogen removal processes can operate in a way that takes nitrite directly to nitrogen. This technique is known as the nitrite shunt. It will allow operators to reduce energy by up to 40% by avoiding a costly and energy-intensive oxidation step. In the area of environmental monitoring, online nitrite and nitrate systems can reduce the incidence of costly non-compliance events. This helps operators avoid fines and also reduces the cost of expensive mitigation. Finally, new companies such as Microvi, Biosys, Nereda, Demon and Sharon have nitrogen removal processes for all parts of the wastewater treatment, tertiary treatment and treatment of nitrogen-rich sludges. Key to optimizing these processes and proving their efficacy is the measurement of nitrite and nitrate. Here we can see what a typical installation on an activated sludge process looks like. The monitor takes a pre-treated sample and continuously, simultaneously and selectively analyzes nitrite and nitrate in the activated sludge. These measurements allow customers to optimize the balance between energy requirements and total greenhouse gas emissions as a vital part of their journey towards net zero. Aeration efficiency can also be optimized by measuring nitrite and nitrate and using the values to allow operators to trim dissolved oxygen levels. In other parts of the process, nitrite and nitrate measurements allow operators to optimize nitrogen removal processes throughout the process. We can see from this slide that the nitrogen cycle in wastewater is complex. It is not enough just to measure ammonia, ammonium, and dissolved oxygen. Nitrate and nitrite measurements will allow process optimization for emissions and for energy reductions. Nitrite in particular is a precursor or final product in many of the processes used for ammonia removal. Here we can see another process where the measurement of nitrite would be of value to a process operator. Ammonia removal processes normally have two stages. First of all, we have a conversion of ammonia to nitrite. The nitrite is then converted to nitrate, and the nitrite is then converted to nitrogen gas. By controlling the process in a different way, based upon nitrite values, it's possible to remove the nitrite to nitrite step. This saves oxygen, which in turn saves energy. Many times in these processes, it is also necessary to add additional carbon. By using the nitrite shunt method, it's possible to achieve savings of up to 40%. So again, we can see that nitrite measurement in wastewater can deliver real value. Nitrite and nitrate monitoring can also deliver value in final effluent monitoring. There is the relatively straightforward compliance monitoring application. Monitors installed in the final effluent channel can give process operators vital information about the condition of their effluent. We are also starting to learn how nitrite and nitrate values in final effluents can give us process information. For example, the presence of nitrite in final effluent indicates that the denitrification step in the process is incomplete. There should not be nitrite in final effluent. Risk models that look at the possibility of emitting nitrous oxide can also make use of final effluent nitrite and nitrate numbers. So, even in final effluent, we can gain information that helps us understand the upstream processes better. Let's look at some real data. 2 aquamonitrix systems were installed on a wastewater treatment plant. One at the beginning of an activated sludge process and the other in the final effluent channel. The activated sludge data shows clear diurnal patterns in both nitrite and nitrate. It also shows a general rising trend in the nitrite value. The final effluent data is also interesting. There are peaks in the nitrite data, which rises as high as 1 ppm. Previous to the installation of the aquamonitrix, it was believed that there was no nitrite present in the final effluent. For the first time, we are starting to understand the forms of nitrogen that are present in final effluent. The aquamonitrix system has the 4 to 20 milliamp outputs, alarms and digital outputs you would expect from a modern analyzer. It is also an internet-enabled monitor, and here we can see the Data Monitrix web portal. Here, an operator has access to the current readings, trends and alarm status. All of the information is at an operator's fingertips, and it can also be transmitted via an API into the customer's data management platforms and SCADA. There are other ways to measure nitrate and nitrate: UV spectroscopy, colorimetry, ion selective electrodes. All of these techniques can be used to measure nitrite and nitrate. Here we see some of the competitive advantages of the aquamonitrix product over other techniques. Key amongst the competitive advantages is the ability of the aquamonitrix to measure nitrite and nitrate selectively. The monitor can make these measurements independent of the matrix. In wastewater treatment processes, this is particularly important as the composition of the sample can change hour by hour or day by day. There is no need to continually recalibrate the aquamonitrix as the sample composition changes. In wastewater treatment processes, maintenance is an important factor. In final effluent, the aquamonitrix does not require any pre-treatment or filtering of the sample. The monitor takes a sample directly from the final effluent channel. A typical maintenance cycle will be a 1 monthly cleaning of internal filters and the frit, which is a ceramic filter in front of the column. On a 3 to 6 monthly basis, it will be necessary to replace some of the internal tubing and valves used in the internal sample handling system. Activated sludge measurement with aquamonitrix will require a pre-treatment. Aquamonitrix supplies two types of pre-treatment system. One is based upon settlement, the other is based upon filtration. These pre-treatment systems will need monthly maintenance. This will involve cleaning of the filters or cleaning of the settlement container. One item which is also in need of maintenance is the ion chromatography column. Once every 2,000 runs, this column will be changed. It is a very simple process which takes around 15 minutes. The system has been designed to be able to function in the arduous applications that we find on wastewater. What are the competitive advantages that the Aquamonitrix delivers? It is a truly selective measurement, capable of measuring low levels of nitrite, even in the presence of high levels of nitrate. The combination of ion chromatography with LED-based UV spectroscopy means that the instrument does not suffer from calibration drift. The equipment has been designed with the application in mind. It has been designed to give minimum maintenance intervals of at least 1 month, even in wastewater treatment applications. Wastewater treatment applications have samples that change hourly and daily with respect to solids content, organics content, etc. There is no need to specifically calibrate an Aquamonitrix dependent upon the matrix. The Aquamonitrix system has been developed by a company with decades of experience in laboratory analysis. The Aquamonitrix delivers results that are as good, if not better, than lab accuracy. How does Aquamonitrix support its customers? Our family of distributors is growing daily. In England and Northern Ireland, we work with PMA, a company with decades of experience in sales and support directly to end users. Delivery and lead times are also important. Aquamonitrix is committed to give the best possible service in this area too. We have analyzers ready for ex-stock delivery. Our facility in Ireland has production capacity for expansion. We have our delivery partners in place. Thank you very much for your attention. I hope you found this presentation informative. If you have any questions, we are right here to help you. Thank you once again.